Welcome back to the 3 episode series of Tech Talk with KD, where we talk to Rohit Sood on 3 diverse topics. The last episode was on quantum computing. Today, we talk about power systems, and trust me, this is an even more exciting episode. If you've missed the quantum computing episode, the link can be found in description. So without doing further ado, let's go ahead and talk to Rohit on power systems. But. Do subscribe the channel Tech Talk with KD on YouTube and don't forget to press the bell icon. Rohit, welcome back.
Thank you, KD.
So Rohit, last time round we spoke about quantum computing. I thought let's talk about classical computing now. And since you've spent so much time, so many years in classical computing as well, I thought, we'll talk about it and get some knowledge from you. Again, the format of Tech Talk with KD is to simplify complex technology so that even a layman can understand. So let's talk about power. I wanted to understand what's the difference between a normal x86 system and a power system.
Let me go back to the history and by the way, IBM was the first one to bring up with this concept of risk in the industry, right, in the world.
Hold on. So first of all, let's try and explain what is a risk, because I'm not sure if the audience is aware of it, and because we want to really simplify it, what is a risk-based server?
So as the name says, KD, RISC stands for Reduced Instruction Set Computing, right? What it means that a processor will be able to process these instructions in a very simplistic term, as we all talk about simplicity, right? In a simple way, right? Breaking them into the smallest particle, and the processor is able to do that in a simple instruction set. As compared to the industry partner, which is called CISC, right? It's called complex instruction set computing. So that's a key difference. But then when you simplify it, how is going to be RISC? I think the purpose by RISC came up as a technology in 1974 by IBM, and the first computer built on RISC was from IBM. I think the fundamental was to deliver efficiency, performance, and the first RISC computer was built to deliver the telephonic connections and the computing required to deliver that connections, and we were able to deliver those 4 times better than as what the complex instruction set computer available that time was able to deliver. And that's how the RISC computing was born. It was to make the processing, the microprocessor, to take those tasks in a simple set and then deliver the performance required to deliver that capability.
Interesting. So in today's date, what are the advantages of a power over an x86 or a RISC-based server on over an x86? And when should an organization think, or which organizations should actually go for a RISC-based server? What's the criteria that somebody says, okay, I really should have a RISC-based server for this processing?
Yeah, I think let me start off by the last one which you said, right? Which organizations? I think all organizations, all industries today will benefit from the IBM Power Systems built with the RISC platform, right? Now to give you a view, when you say power, it stands for something, POWER, right? It's called performance, optimize, workload, enhanced on RISC computing.
Oh, I never knew that.
Yep.
Oh, that's so amazing.
So that's how the power was built on the RISC platform, but IBM took the RISC platform and enhanced it for a business workloads and optimized it required for the performance, right? So there are 3 key advantages, if I want to summarize them into 3. Performance, flexibility and scalability, and the third one, which is very important for today's environment, is security.
Right. So let's go step by step, Rohit. So why do you think the performance is better in Power as compared to an x86?
I think IBM has simplified it. I think when you talk about performance, it is not only about the CPU. I think the performance is relating to an overall systems architecture, right? At power processor at the core, which is the delivering the highest throughput, you have to connect that to a memory architecture. I think when you talk about memory, the bandwidths are humongous. So we are actually 2.5 times as compared to an x86 today when it comes to memory bandwidths between CPU and memory.
Oh, wow.
Right? And the fundamentals is very basic. The fundamentals of performance is if you have something, if you have data very close to the processing where this processing is happening, which is your cache, L1 cache, L0, L1, L2s, L3s, and then the memory subset. You know how quickly you can move the data between these subsystems is one of the key advantages when it comes to performance. And there IBM Power Systems excels a lot, right? So that's how the key performance fundamentals. And when you look at the industry benchmarks today, I think pick up any benchmark, whether it is SAP, whether it is any open third-party benchmarks, I think we will deliver minimum 2x, and depending upon the workload, it can go up to 4x as compared to an x86.
You also said security. So can you explain how is security much better as compared to other systems?
So I think the crux of the security is about finding those vulnerabilities into a platform and ensuring that you solve them immediately, right? But the good thing about Power Systems is since it is the simplified system, by adding what IBM did was they added the hypervisor inside the Power Systems microcode.
Oh, wow.
So you don't need to install, configure this hypervisor like as you have to do in the x86 world. So once the hypervisor is embedded, I think the control of the whole subsystem is to the tune of the capability. If you go and search today an NIST database, which contains all the vulnerabilities detected in this world in terms of systems, search for Power VM, you will not find any single vulnerability being detected so far on that.
Oh,
right?
That is news, and that's amazing.
So your systems are secured, but what we did in the latest generation of Power technology, which is Power 10, we also embedded in-memory encryption capabilities, right? So you are actually doing security at rest, which is on the storage. You are actually doing security when the data is inside the system, which is in memory. All of your memories are encrypted. And today the big challenge of the encryption is if you do it in a standard x86 world, there is a lot of performance requirement to do those encryption and decryptions. IBM have built in additional co-processors which does crypto inside the Power 10 chip to take care of the encryption and decryption, and hence your application is not impacted, and that is why we are calling it as transparent memory encryption on Power 10.
Wow, that is phenomenal, right? And you also spoke about scalability and flexibility.
Yes.
So how is Power more scalable and flexible as compared to an x86?
Right. So have you heard of a system today which has 64 terabyte of memory inside a single physical system? You heard it right? I said 64 TB of not storage, memory, right? That's the memory scalability which we are defining today in the systems. But when you look at, and that's a requirement from the workloads, KD. It is not that we are building just to scale the Mount Everest on the highest peak, right? By putting a benchmark there. The workloads today require that. So when you pick up today's workloads, whether it is in-memory databases, whether it is large data lakes, right? There are so much of data, and we have coined a new phrase, data is a new oil. So these large data sets, when thrown to the computing, right? The computing needs to be able to solve that problem of making sense out of the data. And that's how when you look at these large scalability capability, I think it makes really sense. We have certified HANA databases at up to 32 terabytes. I think it may be increasing as I am talking right now. There are 240 cores of power technology inside a single server available. I think that's a scalability which is unmatched in the industry when it comes to performance. And on top of it, you relate to the performance I said, 2 to 4x. So when you do that, you are actually looking at a system comparable to an x86 system, which will be approximately 240 multiplied by 4, about 900 cores in a single system, which is can't do that today physically in any environment.
Absolutely. So I also wanted to ask this question, that there is a certain myth that the technology is proprietary, when we clearly know it is not.
Yeah.
So I just wanted you, since we are talking today, I just wanted you to touch that point upon that. Why do people say that there is a proprietariness in this technology? I don't see it that way.
Neither do we, Katie. And definitely when you talk about proprietary, I think that's my philosophy, about probably my understanding. It's the most misused word in the industry today, right? So I'll relate it to what we did as the research on IBM Power Systems to help not being proprietary. So when you look at about before 2014, when we have launched, when we were in the Power 7 era and when the Power 8 was coming out, definitely Power 7 used to run only AIX as a Unix operating system. IBM I, which erstwhile used to call AS400, the first integrated database server which IBM made. And in 2017, we were not able to run a Linux which was compatible with the x86 world, right? But in 2014, when we announced Power 8, what we did was we bring in the common endianness, right? So when you talk about endianness, it is all about how you look at memory, save data in the memory, whether a big byte or a small byte, low byte, right? So we actually looked at Power 8 as a technology where we actually made a statement that you can actually take a backup from an x86 server, restore it to a Power. If it comes to a Linux environment, you don't need to do anything else, right? So that's a compatibility which we are talking about. It is no longer a proprietary closed architecture. It is an architecture which is built on an open platform, open Linux platforms. And today we are talking about taking it beyond to the new cloud native worlds.
Yeah. So that was actually my next question. So where do you see, so in the cloud world today, where do you see the role of Power, and is Power able to run the Kubernetes workload, the cloud native workloads that we have today, right? So are we able to do that, and are people using that?
100% KD, 100%. It is actually, IBM, we talk about being, the technology should be available in a hybrid world. It should be available on the cloud, it should be available in your native data centers as well, right? And this is a requirement from data compliance, data positioning capability, right? So when you talk about Kubernetes, I think Red Hat being an IBM company now, I think all the technologies, it is not only about Power. I think every technology is embedding Red Hat's technology in their subsystems. So when you talk about Red Hat technologies, it is Red Hat operating systems, Red Hat cloud native systems, which is OpenShift, which runs on a platform called Kubernetes, right? So 100% Kubernetes or a cloud native applications are supported on Power Systems as well. And to give you a view, we just ran a benchmark, internal benchmark on Kubernetes environment. And do you know what? We were able to deliver 4.3 times performance as compared to an x86 environment.
That is huge.
And this is an open source day trader benchmark which we ran against an x86 and Power on a similar workload on both the platforms. We were able to achieve 4.3 times more performance on the Kubernetes environment on Power Systems. Now what it means for the customers, they're going to help get the TCO benefits when they run Kubernetes on our platform, right?
And this also means that they are able to run much higher workloads on a smaller system, occupying a smaller space. And all that is actually leading to the reduction in carbon footprint, right? And the ESG of the organization becomes better and better because it's reducing the space, it's reducing the amount of cooling that it is requiring because of the space, it is delivering more performance to them, and at the same time, the system is much smaller.
Oh, yeah.
It's amazing.
Sustainability is a key word which is going to rule the future of data centers, right? And that is where efficiently delivering the best TCOs, reducing the carbon footprints, I think that is a way to go in terms of making data centers green.
So Rohit, it was great, but I just wanted to ask one more question because whatever comes from you, ye dil mange more, right? So since you've been associated with power for such a long time, if you can just one small example of a client where you kind of overhauled the complete system of the client and reduced their TCO as well as the carbon footprint. If you can touch that upon.
No, Kelly, it is just beginning of the last year we did a case study with the client, and I'll not name the client, but then I think the case study had the client had 100 database servers. When you talked about 100 physical database servers, they were consuming power, they were consuming electricity, cooling, and they were consuming licenses. We were able to consolidate those 100 physical servers into 2 large power servers. So 100 versus 2 physical servers. Consolidated, dense consolidation. So we did a lot of workshops with them to understand how consolidation will happen. We were able to consolidate those 100 into 2 physical servers, of course running in multiple virtual machines within those physical servers. And you know how much savings which it gives to you? To give you 3 benefits, we were able to reduce their power consumption by half, right? We were able to reduce their cooling environment drastically, right? Both of them are related to carbon savings. And the third thing, you know how much license savings they got? It is almost about 1/3.
That's amazing, Rohit, and it's great to have you on the show, and thank you for your insights. So there we heard Rohit with his expert views on power systems. In the next episode, we talk about how do you make data centers green. Doesn't that sound interesting? Let's catch up in the next episode on Tech Talk with KD on green data centers. Stay tuned. If you like the content, do like, share and subscribe to my channel Tech Talk with KD. Don't forget to subscribe and press the bell icon. Thank you and bye-bye.